Hello friends, today we're gonna discuss about Android architecture. So before jumping to the topic, I like to highlight some of the key features that Android done in its architecture. So Android uses a multi-level architecture in which it have divided itself into a different layer segments. All these layers are interconnected to each other and uses each other functionality. So Android divide itself into a four layers, and that we gonna discuss about it. So the first question that arise in our mind, that why Android using the multi-level architecture. So Android using the multi-level due to a several reason. The major reason for using it, that if some application or some system services, yeah, i- if a one component get failed, it will not take the complete system to crash. That is the one thing that Android majorly focus on. And also there's also a different reason for there's also a different reason why Android using it, is that it will make debugging more easily. And you will better know that where you have made the changes which causing your system to in to doing inappropriately. So so let's begin with Android architecture. So basically Android divides itself in application framework, Android system services, HAL, and Linux kernel. I think most of you are thinking that I have forget the binder IPC proxy, but I will discuss about it. So basically Android application framework is nothing but a framework on which the Android SDK is written. Uh, it will mostly it will mostly consumed and used by the Android application developer, those who are creating the applications for Android. And as a hardware developer, I think you must have to know about the basic of how Android framework will internally using these API, and how they are managing the things. So the another thing is a binder IPC proxy. Let's discuss about binder. Binder is an IPC that is used by Android. Basically binder is a library which is implemented in Linux kernel. It will facilitate two process to communicate each other in a binderized way. So so if application framework wants to call the system services API, call to system services, it have to use the binderized mechanism, because application framework is running on a different process and system services are running on the different process. So to communicate between the two processes, we are using the binderized in this way. The next topic is Android system services. Android system services are modular, and we have divided it into a different segments. Like you can see that activity manager, window manager, and system and other system services. Basically, we have broadly divided it into two categories. That is media server and system server. A media server contain the system services which are related to media, and any other services other than media services are come in the category of system server. Mostly if you create a server, mostly you will create in a system, if you will registered it in a system server. The next thing is HAL. A HAL basically is a hardware abstraction layer. It will it will agnostic the it will agnostic the Android framework. It will So our next topic is HAL. A HAL is a hardware abstraction layer, which will provide an interface between Linux kernel and system services. Android Android system agnostic about the lower level implementation, and it will not care about what is happening in the at the lower level. If we have changed something at the lower level, it minimally it will minimally impacting the higher level. Same thing is happening at vice versa. So our next topic is Linux kernel. A Linux kernel is a simple it is a kernel that is used in Android. Android uses to creating a new hardware in our system. We have to create a driver for that, and creating a driver is more similar to writing a Linux driver. Okay, thank you.